My research was on the probability of interbasin transfer of stoneflies. Stoneflies are commonly used as indicator species of water quality, but within Philadelphia, I don't know if you can see this map, there's not a dense network of streams. It's very urbanized. Outside of Philadelphia, you have a lot of streams that are very close to each other. So within Philadelphia, if we clean up the water, there's a question whether or not these insects are going to return. So my study was to go out into the forest, trap adult stoneflies as they fly around at various places, and then to kind of extrapolate from that, build a computer model to simulate their flight, calibrate it to the field observations, and use that to predict the probability of transfer. The probability is actually better than we imagined. We were thinking, like a lot of the existing research to this point says that these insects stay right within the stream. They don't really go more than a couple 100 feet away. But my research predicts that actually a few of them will go far away. Some of them can get up to a mile away. And that if we clean up some streams in Philadelphia, we could expect to see them return on the order of 10 to 15 years. They're an indicator of the water quality. So if, say, we get money to clean up the stream, and we have to prove that we spent the money in a smart way, we have to prove that the stream is now restored. One way to do that is to go and look for stoneflies or other sensitive insects. If they're not there, the assumption would be that the water's not clean. And this research is kind of suggesting that no, the assumption is maybe wait longer for them to return.
Rain gardens are essentially a shallow depression that is excavated into the land, and you can either extend downspouts to it or you can collect surface water. They're planted very densely with native plants, and the idea is to really infiltrate that water on site. So we're trying to keep water on site instead of the old practice, which was get water off site as quickly as possible. So through rain gardens, we keep everything on site, we infiltrate it back into the water table, and we're just decreasing a lot of pollutants that surface water picks up. They're also really beautiful to look at, so you end up with a really nice garden at the end of it.
We have handled the water chestnut through a lot of volunteer hand-pulling work days. We have tons of volunteers who love to come out year after year, and we take everything on shore and we compost it, and the compost is hot enough to kill the seed pods, which otherwise could live for 12 years. And the plant also reproduces vegetatively, so if we miss a piece of the root or the stem, we could just be spreading the plant. So we have to do this very carefully. The infestation at Lake Delmont was getting so out of hand we could not weed it with just volunteers before it would flower and produce new seed pods for the next year. So we started doing chemical treatments, and we've done those twice now. And with the help of those chemical treatments, we've been able to decrease the amount of cover that water chestnut is taking over the surface of the pond, the impoundment. We've been able to reduce that from about 70% coverage to 10% coverage. So now it's really manageable to go out there with volunteers and stay on top of it. Until we get rid of all of the water chestnut, we still have 12 years to wait to see if any of those seed pods start to germinate later on. So we're now monitoring 5 different lakes or ponds, and we're worried that geese may be spreading it. So we're asking everyone who stops by our table today to take a little card that has our phone number on it, and please report any sightings of water chestnut to the Perkiomen and Watershed Conservancy so that we can either handle it in our watershed or report it to the appropriate agency or organization in another outside watershed.